Okay, guys, how are you doing? This is another problem that I'm bringing for you today, and this is a really complete problem for this part. Let's read the problem. A bent rod is supported at A, B, and C by a smooth journal bearings. Compute the X, Y, and Z component of the reaction at the bearings if the rod is subject to forces F1 is 300, F2 is 250, and F1 lies in the YZ plane, and then you have the direction here for the F2, and they say the bearings are in proper alignment. Okay, what do we have? What do we know about this problem? First, it says that it's smooth. By smooth meaning it can slide in that direction. And then it says proper aligned. And this is really important, that part that says proper. Because when you say properly aligned, there's only force reactions on the rod. It's not that the bearings cannot withstand any moment, because they can. It's that the moment isn't going to be produced. So that basically simplifies our calculations a lot. What else do we know? We know that F1 is 300 pounds, and it's we have the angles in the YZ plane. We know that, and we know also that F2 is 250 pounds, and we know the projection angles, which are these angles here. So basically we have everything that we need to do, and ask anything that we need to know, everything that we have that we need for solving the problem. And we asked to calculate the reactions at A, B, and C. A, B, and C. How I'm going to approach this problem? Well, this problem I'm going to solve it just by equation of equilibrium, scalar formulation. That's what we're going to do. If you want, you can solve it later by using vectors, Cartesian notation, but I'm not going to do that. So we have to use, I'm going to use equation of equilibrium, scalar equation of equilibrium, and because we are in 3D, remember we have 6 scalar equation of equilibrium, and we should just check the number of reactions that we have. Because they're, once again, properly aligned, there's no moments there are not going to be moments produced, which doesn't mean that the bar couldn't have a moment applied. The bar could have a moment applied. In this case, we don't have any, but you could have a moment. But in the reactions, there are not going to be any moment produced. So let's start with this one. With this at A, I'm going to have a reaction going in this direction, which is AY. And I'm going to have a reaction going in this direction also, which is AX. There's no reaction in the Z direction because of their smooth journals. In this part, same thing. I'm going to have a reaction here in this direction, CY, I'm sorry. And I'm going to have another reaction here, which is called CZ. And what else? In B, I'm going to have BZ. And I'm going to have this reaction here, BX. Those are my reactions. 1, 2, 3, 4, 5, 6 reactions, 6 equations. Yes, we can solve the problem, theoretically. So let's start by finding the components of these forces. And the component of this force F1 is going to be, this is going to be one of the components, and this is going to be another of the components here. This component is going to be F1 multiplied by cosine 45. I'm going to just express F1 as a vector, even though I don't have to. It's going to be the magnitude of F1, which is 300, multiplied by this one. First of all, this is going to be YZ plane. So this is the Y direction, right? So it's going to be negative cosine 45J. And this one is going to be negative sine 45K. I don't have to do this. I'm just doing it because I find easier to keep the values like that, more presentable. That's it for presentation purposes. 212, negative 212.13J, negative 212.13K. That's my force F1. I don't need to express this as a vector unless I am asked to, but what I need to know is that this value here is 212.13 and this is 212.13. And remember, the units are pounds. What else? This other force. For this other force, for F2, what I'm given are the projection angles. So if I want to convert this force, F2, and resolve it into the components, well, I'm going to have this component acting here, this component acting here, and this component acting here. And I have these two angles here. Remember how we did this last time? First we calculated this projection over that plane, and then we go cosine and sine. And for the Z1 is directly the sine of this angle. So let's do that. F2 has a magnitude of 250 multiplied by, let's start with the x direction. X direction is this, but first I have to calculate this. What is this? This is F2, and this is cosine of 45. And when I put it here, it's sine 30. Cosine 45, sine 30 in the I direction. And in the y direction, it's going to be this other one, but it's going to be also cosine 45, which is this one, and then I put it to the other side, cosine 30. In the j direction. And for the z direction, which is this one, it's just going to be negative sine 45 in the k direction. So F2 is going to be 88.39I plus 153.09 J minus 176.78 K. Once again, I don't need this like that. The only thing that I need to know is that this value here, this force, is going to be 88.39. This other force is going to be 153.09, and this other force is going to be 176.78. There you go. Now we start applying our equations of equilibrium. So if we say summation of forces in X equals 0. Let's start with that one. X is this direction. What do we have in X direction? I have AX, I have VX, and I have this value here, which is 88.33, 39. That's 0. That's my first equation. Secondly, summation of forces in Y equals 0. What do we have in Y? Y is this direction. I have AY here. I have this force going in that direction, which is negative 212.13. I have this component, which is positive 153.09, and I have CY, which is also positive, equals 0. So basically, if I combine this with this and these two terms, then I have AY plus CY minus 59.04 equals 0. Second equation. I'm going to express this as AX plus BX equals negative 88.39 and this one I'm gonna express it like AY plus CY equal 59.04. Just passing the independent term to the other side of the equality, the equal sign. Now summation of forces in Z equals 0. What is Z? What is Z? What is Z? Z is this one. Negative 212.13. Positive BZ. Negative 176.78. Positive CC equals 0. And from here I can get another equation, which is BZ plus CZ equal 388.91, and that would be my third equation. Now the problem is, look, AX, BX, AY, CY, BC, CZ, there's nothing that I can still work with. So let's keep working. Now the next thing that I'm gonna do is, same place here, I'm gonna now start with the moments. And let's start with summation of moments about x-axis. And this moment you can take it whatever you want to take it, but I'm going to take it with respect to the origin that is over there. So with respect to the origin, let's do that moment about x equals 0. And let's start with this force. Whatever is rotating this about x, this force is making it rotate about x. So it's going to be, and if I put my pin here and I apply this over here, the rotation is going to come going into the axis. So it's going to be negative, because it's going to be negative, the direction, and the distance is 3, and the force is BZ. Okay, that's for this one. What else? I have this other force here, AY. If I'm here and I plug this, I push this into here, it's the same thing. It's going to be rotating about the negative part of the axis also. So this is going to be negative. The force is AY, and the distance is 4 here. Now this force is also producing that, the moment, but in this case rotation is positive, is coming out because that force is pushing it into this direction, and it's making the rotation about the axis going like that, and the distance is 5. So it's going to be positive 5 multiplied by 212.13. Anything else? Anything else? Anything else? None of these three forces are producing anything because they are applied there. Now this force produces about y-axis, and this force produces about z-axis, and there's nothing else here. What about this force? I'm missing this force. Look, if I push it here, rotation is going to come in this direction also, which is going to be also 5, because now the distance from here to here is 5, multiplied by the force, which is 212.13, and that's equal 0. And from here I can get an equation that says 3bz plus 4ay equal 21.30, and that will be my equation number 4. Now equation number 5. Let's see what do we do with summation of moments about y-axis. Y-axis is this one. Let's say this force and this force, this is over the y-z plane, so those two are not producing anything with respect to this one. This force here is producing about the x-axis. What about this force? This force is not AX like that. Yes, because if you see you have this here, and if you apply the force in this direction, this is going to rotate also about the positive direction of x. So it's going to be ax multiplied by 4. Which is the same thing that is going to happen with, not with this, because this one is going to make rotation about z, but this one, if I push this up, is going to be rotating about x, so that it's not that either. What about this one? CZ, if I push it up, this is going to be rotating in this direction, which is going in y. That's correct. So that's going to be positive 5CZ. And what about this force? This force is just producing rotation about C. So there's nothing else equals 0. That's your fifth equation. Now, what is my sixth equation? Summation of moments about z equals 0. That's the sixth equation. Let's do that. Z, this one is the axis. Let's see what is happening here. This force is in the plane. These two forces are in the plane also. Let's say if I push this in this direction, that's going to produce a rotation that is going to come around the z-axis. A second, please. Okay, summation of force moments about z. Summation of moments about z, we were saying that this force here is producing a moment about z, which is going to be ax times 5ax. This is not producing anything. This force here, bx, if you apply the force bx here, also is going to make a rotation going in that direction, like that. So it's going to be bx times 3, and it's going to be positive. What else? This force produces about x. None of these three forces produces. This force here, CZ, produces about y. This force here, CY, is going to produce a rotation in this direction, and that rotation is about c, and it's a negative rotation. CY is a force, distance is 5. And this is my equation number 6. Now, how do we solve those equations? Because we have 1, 2, 3, 4, 5, 6 equations. Well, you can start combining them by hand, and probably it's going to take forever to do it, but you can do it. Or you can make use of the resources that you have. A lot of you guys have calculators, and they are graphing calculators and scientific calculators and allow for matrix operations, and you don't have any clue how to use those calculators. Well, let's use a method for solving system of equation which is based on matrices and matrix inversion that I'm pretty sure that you studied that before. So let's say that you have a matrix A, and that matrix A, which is n rows and m columns, multiplied by a vector or a matrix of variables x, which is going to be m by 1. These two, remember, has to be equal in order to do the multiplication of matrices. And that's going to be equal to another matrix of independent terms, which is going to be m by 1. So if I want to solve this, and I say this is my matrix A, this is my matrix B, and this is my matrix X and my matrix B, I can multiply by the inverse of A, and if I multiply this by the inverse of A here and A here, these two basically cancel each other out, and what I'm going to have is that my unknowns X are going to be equal to the inverse matrix of A multiplied by the independent terms. So that's what we're going to do basically, and the calculator does that for us. So what I'm going to do is I'm going to put here all my equations. my first, this is equations here. Let's put equations here. This is 1, 2, 3, 4, 5, and 6. My 6 equations. These are going to be my variables. These are going to be AX, AY, BX, not my variables but my coefficients for each one of them, BY, CY, and CZ, because those are my reactions. This is going to be equal to, and here's going to be the independent term. Okay, let's start with the coefficients of the equations. Let's start with the first coefficient here. This is my first equation. Equation number 1. So my coefficient for AX is 1. This is 0. This is 1. And the rest are 0. And my independent term is negative 88.39. My second equation, equation number 2, is this one here. So we have AX is 0, AY is 1, and CY is 1. The independent term is 59.04, and the rest of the coefficients are 0. My third equation, which is this one here, BZ is 1. What is BZ? I don't have BX. This is not BX, this is BZ. BX and BY is not BY, it's BZ. Okay? BZ. So BZ is 1, CZ is 1. This term is 388.91. And the rest of the coefficients are 0. My equation number 4 is right here. I have BZ is 1. BZ is negative 3. No, BZ is 3. AY is 4. And the independent term is 21.30. And this is 0, 0, 0, and 0. And the number 5 is this one. AX is 4, CZ is 5, independent term is 0, and all the rest of the coefficients are 0 also. And now, my sixth equation, which is this one, I have AX is 5, BX here is 3, CY here negative 5, independent term here 0, and the rest of the coefficients is 0. And now we have to use this approach. How do we do that? Well, now you need your calculator, unless you want to do it by hand. And I'm using the TI-83 instead of using one more advanced calculator, just for showing you that you can do it. Basically, it doesn't matter. So what you're going to do is that you're going to put your coefficients, these coefficients, and we're going to create a matrix called A. The matrix that you can see is 1, 2, 3, 4, 5, 6 by 6. And that's the first step. The first step is creating that matrix. You have the function matrix here, second matrix, and that's the function matrix. And I already created before because I studied, I was solving it, but I'm going to create a new one in 3 here. You can select any one of those. And you're going to select one of them and you're going to go to edit. First, you go to edit. And when you go to edit, you're going to go to the matrix that you want to use. I'm going to use the matrix C for that. I'm going to put there. And then the first thing that the calculator asks is how much for how much. It's going to be 6 by 6. As soon as you put that and you hit enter, a 6 by 6 matrix is generated here. Now the only thing that you have to do is start introducing the coefficients. You see here, coefficient 1, 1, that corresponds to that one, and they correspond to this one here. So it's going to be 1, 0, hit enter every time, 1, 0, 0, 0. Then the second one is going to be 0, 1, 0, 0, 1, 0. The third one is going to be 0, 0, 0, 1, 0, 1. Remember that you have to hit enter every time that you do that. The other one is the fourth one. You see there's asking here 4 by 1. So it's going to be 0, 4, 0, 3, 0, 0. And the fifth one is going to be 4, 0, 0, 0, 0, 5. And the sixth one is going to be 5, 0, 3, 0, -5, and 0. There you go. For leaving these, you have to quit. You say second, quit. Now if you want to see, you hit enter, and you just left that part, right? So if you want to see the matrix that you just created, you come second, matrix, and now you look for the matrix that you just created, which is the matrix C, this one, and you hit enter there. Matrix C, this is the matrix C. You see 1 0 1 0 0 0, 0 1 0 0 1 0, 0 0 0 1 0 1, 0 4 0 3 0 0, 4 0 0 0 0 5, 5 0 3 0 -5 0. This is the matrix C. Now same thing. Now we have to introduce the independent term. The independent term is this one here. So we're going to do the same approach. Second, matrix, edit, and then we're going to go to the D. I'm going to create a new one called D. And what is the dimension of this? This is 1, 2, 3, 4, 5, 6 by 1. 6 rows, 1 column. 6 by 1. Hit enter and start introducing your coefficients. First one is -88.39. Second one, hit enter. Second one, 59.04. Hit enter. Third one, 388.91. Hit enter. 21.3. 0, 0. Once you have it there, quit. Second, quit. And if you want to check it, second matrix, you go to this D, hit enter. That's the matrix D, the vector D. Hit enter. -88.39, 59.04, 38.91, 21.30, 0, 0. That's it. Clear. Now we are ready to do the calculations. What do we have to do? This inverse. It's not going to be A in this case because I named it C, and B is not going to be B, it's going to be D, but that's the way we're going to do. So second matrix, and then I'm going to select here the matrix. I'm going to select the matrix C, and I'm going to say the inverse of that matrix, inverse, multiply by second matrix D. D. There you go. You see the equation? Inverse of C multiplied by D. Now hit enter, and there you go. Those are your results. Then you get those results, and you copy your results in your page. This is gonna be results. $632.84, -141.06, -721.23, 895.18, 200.10, -506.27. You have to put the corresponding units to each one of them, and then you have to identify each one of the variables, because this one is going to be AX, AY, BX, BZ, CY, and CC. So you know this is going to be, all of them are going to be for this problem in the units that we were working, which are pounds. If you have the TI-84, it's the same procedure. If you have the platinum, the same procedure. If it's not the same procedure, it's going to be something really similar to that. So guys, if you have the tools, use them, but you have to learn. What is the easiest way of learning how to do or how to solve a system of equation with the TI-83? It's not waiting for your professor of statics to come and show you how to do a problem. Nowadays, you just go to YouTube or Google any page, but you go to YouTube and you write how to solve a system of equation using a TI-84, for example. And I can guarantee you that you're going to have 356,000 hits in less than 0.1 second in 20 different languages. So there's no excuse for that. If you don't know how to do it, it's because you didn't care enough how to do it. Well, anyway, I hope this is going to be, and this has been productive for you, this lecture, these solutions for this example. And well, next time I'll solve more examples. Enjoy, guys. Thank you for watching.